Hi, my name is Sylvia, and the problem I have today is from stoichiometry, problem 14. 6.50 grams of aluminium react with an excess of oxygen. How many grams of aluminium oxide can be formed? This is what we have. Okay, as professors know and trained us, every time we see react, we know that we have to think about reaction. We need to write a reaction equation. This table is something I'm very comfortable with, so this is what I'll be using. But if you're comfortable with something else, go ahead and use it. So, as it states, it says aluminium. So for the first thing we're going to put is aluminum plus oxygen. Oxygen is a diatomic, so automatically you always need to put a 2. And it reacts to become aluminium oxide. So aluminum will have it will have a 2 and oxygen will have a 3. So in this case, we will have to balance it. So I decided to put a 2 to make aluminum 4 and oxygen a 6. And on the other side, oxygen will become a 6 and aluminum become 4. And that means it's a balance. So now we could go ahead and get back to the problem. So it says that we have 6.15 grams of aluminum. That is a given. So we're going to put it the aluminum side. However, before we do anything, we have to convert it into moles. So this is the part. We write 6.50 grams of aluminum and we convert it into moles. So we go at the top we will put 1 mole and at the bottom we're going to put grams. And here we go back to the periodic table to find the molecular weight, which is 26.88. This is where we'll put it at the bottom to cancel out the grams and go into moles. While you put in the calculator, the answer will be 0.240192 moles of aluminum. It's good to actually keep a lot of significant figures so your rounding will not be totally off and you might not get the wrong answer. So we're going to transfer the same number 0.240192 to the LR, which is considered the limit reagent because that's the only thing we have. So we're going to write the same number on the aluminum oxide side because we want the most of aluminum oxide. So at the bottom we're going to write moles of aluminum because that's what we're trying to cancel out. And at the top we're going to write aluminum oxide because that is the most we're trying to get. So for aluminum we're going to write a 4 because that's what it says. Aluminum is 4. And for aluminum oxide we're going to write 2 because on the balance equation there's a 2 at the top. So after putting it in the calculator, our answer is 0.120096 moles of aluminum oxide. However, the question did not ask us the answer in moles in aluminum oxide. They said grams. They said how many grams of aluminum oxide can be formed. So we will have to convert it back into grams. So we'll be using the same number, 0.120096 moles of aluminum oxide, and we'll be converting it into grams. So at the bottom we know that we're trying to cancel out moles of aluminum oxide. And at the top we want the grams of aluminum oxide. So that will always be the order. So we want to cancel out the moles. So what we'll be doing right now is finding the molecular weight of aluminum oxide. We know that aluminum is 26.98, and we will be multiplying it by 2. And oxygen is 16 times 3. I'm fast forwarding it. And the answer will be 101.96 grams. So that will go at the top. And at the bottom will be 1 mole. So if you put that in the calculator, the answer is 12.24 grams of aluminum oxide. So now we could actually go back and check with our multiple choice answer and see if our answer is there, and it turned out it's there. Thank you so much for watching and have a great day.